So good morning, everyone, and afternoon for some of you, and welcome to our Alaska Collaborative on Health and the Environment teleconference titled Plastics and Chemicals in the Marine Environment, Effects on Seabirds in the Bering Sea and on Global Marine Ecosystems. Our guest presenters today are Veronica Padula, graduate at the School of Fisheries and Ocean Sciences at the University of Alaska, and Christie Keith of the Global Alliance for Incineration Alternatives, or GAIA. My name is Diana DeFazio, and on behalf of Alaska Community Action on Toxics, I'll be facilitating today's call. SHEA Alaska is a regional partnership group of the National Collaborative on Health and the Environment. And SHEA Alaska aims to advance knowledge and effective action to address growing concerns about the links between human health and environmental factors. Is that Veronica?
Yeah. Can you hear me?
Okay, great. Thank you. I'm just going to continue on, but you can go ahead and mute your line until it's time to speak.
Thanks.
Okay. You can find more information about SHEA Alaska and SHEA National at the following websites: akaction.org and healthandenvironment.org. I sent everyone an email about an hour ago with a link to 2 PDFs of presenter slides. Veronica Padula will be speaking first, followed by Christie Keith. In addition, I sent the second part of Christie's presentation as an attachment, so look for the email with the subject, Break Free from Plastics. This one is a PowerPoint slideshow with animations, and I was unable to upload it to our website. So Christie will say click, and then when you click, the content will show up on your animation. Check your spam folder if you can't find that email. And if you signed up late for the call and don't have these documents, please send me an email, diana@akaction.org, and I'll send you the links and attachment very shortly. Excuse me. Now it's my pleasure to welcome and introduce Veronica Padula. Veronica was born and raised in New Jersey, where she studied ecology, evolution, and environmental biology at Columbia University in New York City. She became passionate about birds after interning with Wildlife Trust, where she investigated the health of black-crowned night herons in New York Harbor. She later worked on a marbled murrelet project in Southeast Alaska. And Veronica received her master's in fisheries from the University of Alaska Fairbanks in 2013. She's currently working on her PhD at the School of Fisheries and Ocean Sciences at UAS, investigating the impacts of plastic marine debris on seabirds from the Bering Sea. So you may go ahead and begin, Veronica.
Thanks. So good morning, everybody, and thanks for calling in. So if you are checking out the first slide of the PDF, this is plastic marine debris. It's what you don't see that could be harming seabirds, and this is sort of the crux of my research for my PhD. And I wanted to start off with a little bit of background about what plastic sort of does to the environment and how it can be harmful to the environment and the organisms that live in it, including humans. So if
can you hold on?
Next slide.
Oops. Can you just hold on one moment? I just want to check with the ACAT office and ask if you can hear Veronica okay. I'm having a little bit of trouble, but I want to make sure it's not just my phone.
Hi, Diana. Veronica, you're just a little bit unclear, a little bit breaking up. Muffled.
So maybe move closer. If you're on speakerphone, maybe move closer to it. And if that still doesn't work, you might have to hold the phone if we're still having a little trouble hearing you.
Okay. I wonder, so I'm speaking through my mic, but I wonder if my mic is just a little messed up. Give me, let's see what's happening. Can you hear me okay if I talk through this?
Yes, that's much better.
Okay.
Yeah? Okay. All right.
I apologize.
Now,
my mic
that's all right.
I didn't realize my mic was messed up.
This is good now.
So if everybody is sort of on the next slide, it says humans use lots of plastic. And plastic is just this material that we've used sort of throughout our lives, and it's kind of just a part of our lives. In the U.S., Americans discard more than 30 million tons of plastic each year, and only 8% of that gets recycled. So a lot of it is ending up in landfills and in waste treatment plants. And it's either getting incinerated or it can become litter, which is the problem that we're facing with marine debris. So if we move to the next slide, if we don't take any action in terms of the amount of plastic waste that we're creating, over 150 million tons of plastic is in the ocean today, and that will increase as we move forward. And it's expected to contain 1 ton of plastic for every 3 tons of fish by 2025, And if we continue with no action against plastic debris beyond that, by 2050, we're expecting to have more plastic than fish in the ocean by weight. So if you move to the next slide, the big question becomes, are we creating a plastic ocean? Are we just filling our oceans with this material? And bear in mind that plastic is actually not biodegradable. It doesn't break down into something that can be reused by the environment. It'll erode into smaller and smaller pieces, but it'll never leave the environment once it's there. So that brings me to sort of what I do. And what I do is I look at, next slide. And what I do is I look at how this plastic marine debris impacts marine organisms, and specifically seabirds. But marine organisms in general are really susceptible to this plastic pollution that's entering the oceans, mainly because they can either get entangled in this debris or they can mistake this debris for food and ingest it. So next slide, it'll have a picture of turtles stuck in a net, and this picture was taken in Brazil, and there's a big phenomenon that's happening these days called ghost fishing, which is what happens when fishermen out at sea might lose their gear. Often, fishermen are tending to their nets, always watching them, but accidents happen and sometimes nets and traps are lost. And just because humans aren't tending to those nets, they still will do their job of catching things. They'll float around in the ocean and trap animals. And sometimes they'll trap animals that actually need to get to the surface of the ocean to breathe. And eventually what happens is those animals will drown because they're trapped. They can't reach the surface to get oxygen. So we've seen lots of incidents, especially in Southeast Alaska, of whales getting tangled up in fishing line and the ropes from crab nets, and they can't make it to the surface. And so there's a whole scuba network along Southeast Alaska that goes out to rescue whales if they're reported. If you move to the next slide, I like to use this picture of sea jellies versus plastic bags in these containers. If you look really closely, you can see the difference, and you can probably figure out which one is the plastic bag and which one is the sea jelly. But for animals that normally rely on sea jellies for food, they're not going to know the difference between a sea jelly and a plastic bag. They didn't invent plastic bags. They don't know what they are. And so to them, if the plastic bag has the shape of the sea jelly, then they equate it to food. And so another thing that's happening across the ocean ecosystem is that things like sea turtles, which really rely heavily on sea jellies, are found full of plastic bags because they're just mistaking those for food. If you move to the next slide, a recent study came out from Chelsea Rockman, who found that 25% of the fish sold in markets in Indonesia and California had plastic in their stomachs. So these are fish that people are eating, and those fish are eating plastics. So if you think about the way food webs work, that means that essentially the people that are eating those fish are getting exposed to whatever's in the fish, including those plastics, and including the sorts of chemicals that might be on the plastic. If we move to the next slide, the other thing that's happening is that when plastics are in the environment, they're breaking down into smaller and smaller pieces because the ocean waves are eroding them. And they'll break down into pieces so small that we actually call them microplastics, which would be pieces of plastics that are about less than 5 millimeters in size. And those really tiny pieces can get mistaken for food by really tiny organisms like plankton, or they can get incorporated into cell walls because they can get so small. So plastic is just entering all parts of the environment. The other thing that's really crazy about these microplastics is that if they're getting washed back up onto a beach, they can actually get mixed in with the sand, and you could barely tell the difference between sand grains and microplastics. Also, there are other studies coming out that show that these microplastics are ending up in sea salt also. So when you evaporate the water away and get sea salt, some of those pieces, you might mistake them for salt, but they're actually plastic. So that's also happening. So if you move to the next slide, specifically I want to tell you guys about seabirds and plastic ingestion. And on that side is a black-legged albatross, and albatross are sort of these poster children for plastic ingestion in organisms. There are lots of albatross that are literally starving to death because they're mistaking pieces of plastic for food. If you move to the next slide, why would I look at seabirds? Seabirds are really important indicators of marine ecosystem health because they are often at either the top of the food chain or sort of close to the top of the food chain in a lot of their ecosystems, and so they're getting impacted by all the things that are happening in other trophic levels. The other thing is that for scientists, seabirds are actually really great to study because they spend a part of their life on land. They have to come to land to build their nests and lay their eggs. And so those are periods of time where humans can actually see what's going on with them, and they can actually observe what kinds of food they might be eating and things like that. So seabirds have really been helpful in gaining better knowledge of what's going on with marine ecosystems. Birds in general have also been really great environmental indicators across the spectrum when we think about contaminants. So if you think back to Rachel Carson and Silent Spring, understanding that pesticides like DDT were harmful to human health actually first came from observations of declines in bird populations. If you move to the next slide, where I do my work is the Alaska Maritime National Wildlife Refuge, specifically in sort of the Western Aleutian Islands and the Pribilof Islands. And the reason that we work out there is because the Maritime Refuge harbors the largest proportion of breeding seabirds in North America. So these islands are highly productive, and birds really love to get out there and live on those cliffs and grab all the food they can and raise their babies. So it's a really important area in terms of thinking about seabird health in general and thinking about where we look to monitor the ocean and more specifically things like the places like the Bering Sea. If you move to the next slide, my question is, are seabird populations in the Bering Sea impacted by marine debris? And so how we do that is we collect seabird samples, we will dissect them, we look inside their stomachs to see if they're ingesting any plastic, and then we'll also take pieces of their muscle tissue, their reproductive tissue, their feathers, their preening oil, all different sorts of tissue, to look for specific chemicals in those tissues that are associated with plastics. If you move to the next slide, are the seabirds eating plastic? The answer is yes. Not every seabird that we have dissected has had plastic in their stomach. About a quarter of the birds that we look at, and that ranges across the spectrum of the seabirds that we're of the seabird species that we're investigating. So we look at all the birds that are breeding in this region where we have a sample from them. We're looking at whether or not they're ingesting plastic, and so it isn't really specific to one species that is having plastic in their stomach, but overall about a quarter of the birds that we've looked at. And more often than not, it's these microplastics that we're finding inside of the birds, so these small pieces of plastic. And that's really disconcerting for us because it isn't necessarily going to starve the bird to death because it's not eating giant pieces of plastic that will get stuck in its stomach and keep it from ingesting other foods. There's a possibility that these pieces of plastic are so small that it'll actually just pass through their intestinal system out the other end and won't harm them in that way specifically. But that raises a lot more questions. So if you move to the next slide, the big question it raises for us is, if these birds aren't necessarily starving to death from ingesting plastic, are they getting exposed to anything else from the plastic while it's in their system? Specifically, these chemicals that are associated with plastic materials. Now, we've known that there are contaminants in the environment for a really long time, and we try and trace what kinds of contaminants are moving where. So big examples in Alaska include PCBs, which are a type of persistent organic pollutant associated with industry and military use. Mercury being another one that we're often concerned with. In the environment, there are approximately 60,000 to 80,000 chemicals on the market today, and a lot of them aren't tested for safety to humans or animals or the environment under the laws that we have. And about 80% of them are polymers and plastics. So of those 60 to 80,000 chemicals, a lot of them are associated with this plastic material. And health and science authorities estimate approximately 1 in 5 cases of cancer are caused by chemicals and environmental exposure. So putting these contaminants into the environment links back to our own human health. We get exposed to them through water, through air, through the food that we eat, and it can come back to haunt us somehow. It's not very good for our health to be exposed to these contaminants. If you move to the next slide, the chemicals that we're specifically interested in are called phthalates. And phthalates are esters of phthalic acid. If you look on the slide, that's sort of the generic chemical structure of a phthalate. There are 25 kinds of phthalates, they're congeners. The R on that chemical structure represents the different chains that make up those each of those 25 chemicals unique. So R could be representative of a number of different sorts of chemical combinations. They're plasticizing chemicals. It means that we add them to plastic material. So in general, we have 7 categories of plastic. If you sort of have a water bottle near you or like a soap bottle near you and turn it over, there's a triangle usually imprinted on the bottom of the bottle, and it has a number inside. And so often with like your standard water bottles, it'll have a number 1. That represents polyethylene. That's the type of molecule that makes up that plastic. And so like number 3 is PVC. Number 5 is PP, polypropylene. Number 6 is your styrofoam, so polystyrene. And those molecules by themselves might not necessarily do the job that a manufacturer wants that material to do. And so what they will do is they will add this extra layer of chemicals to the plastic to give it certain characteristics. So for example, if you want to waterproof a material, you might add one specific phthalate. If you want to make a piece of plastic more malleable, you might add a different kind of phthalate. If you want to add clarity, you might add a different kind of phthalate, and so on and so forth. And because they're coating the plastic, they're not part of the matrix that actually makes up the plastic material, which means that they're susceptible to leaching. It means that it can easily come off the material and get into the environment. Or it can also get into the air. Phthalates can easily aerosolize off a material, and we can be breathing it in. So if you move to the next slide, why do we care about these chemicals? Well, phthalates are shown to be endocrine disrupting compounds. It means that they look like hormones. Hormones are these chemicals that we naturally synthesize in our body that tells our body to function. So for example, insulin is a hormone that we have inside of our bodies, and it helps us regulate our sugar levels. People who are diabetic don't have good regulation of their insulin and therefore need extra insulin to be entering into their body in order to regulate their sugar levels. Our hormones are very much involved in our reproductive health. Estrogen, testosterone, those are the things that help us function day to day. And so an endocrine disrupting compound is a chemical that is not a hormone. It's a chemical in the outside environment that when it enters our body, its chemical structure looks so much like a hormone that our body gets confused. And so if you move to the next slide, I'm sorry, I forgot to say to the next slide, you can see that even though the structures of the phthalate, of basic chemical structure of the phthalate, doesn't necessarily look exactly the same as, say, a testosterone or an estrogen, it's similar enough for our bodies to get confused. And actually, a lot of these chemicals look like estrogen. So estrogen mimics entering our body can sort of cause some problems for our health, and I'll get into that in a moment. If you move to the next slide, this is just an example of how an endocrine disrupting compound might interrupt our hormone receptors. So if you think of the block shape as sort of the outside of our cells have these little lock and key mechanisms on the outside that allow certain chemical structures to enter the inside of the cell and to keep other chemical structures out. So it's like this doorway. And if you have the right key, you can unlock the doorway and get into the cell. Well, some of those doors are meant for hormones. If you have this outside chemical, you can actually, it's basically like it copycatted the key, and the door gets confused and lets that chemical in, even though it's not actually the hormone. The other thing that it might do, it might block the entrance altogether, so it won't let any action happen, or more often than not, it's actually way more complicated than that in terms of the response that happens when these endocrine disruptors get into our body. If you move to the next slide, in terms of phthalates, what we know of phthalates' negative impacts on health comes from human studies. And so these studies are ongoing in terms of thinking about the sort of consequences that happen when phthalates enter our body. But some studies have shown that phthalates can affect ovarian and oviduct function in females, can reduce fertility in both men and women. So there are some studies out there in the U.S. that show much higher rates of infertility in men, and those men who have the higher rates of infertility have more exposure to plastic items. And so they're starting to build this understanding that maybe these phthalates are really impacting male fertility. Also for women, proliferation of uterine tissue and breast tissue, carcinomas and increased breast cancer risk, reduced numbers and or function of Sertoli and Leydig cells, which are associated with your sperm, and reduced gonadal function. Another thing that happens is that there are studies right now showing that puberty is happening earlier in adolescence, and they think that it's possible that early onset puberty is associated with exposure to endocrine disrupting compounds. Maybe not necessarily phthalates, but just endocrine disrupting compounds in general. Another thing that they're starting to show is that if babies are exposed to endocrine disrupting compounds in utero, there's a higher risk of having a lower IQ. So that's another association that's popping up right now in terms of understanding what endocrine disrupting compounds might do to human health. So if we move to the next slide, the question for me is, are the birds that I study exposed to these compounds also? Because they're ingesting plastic, and maybe they're not starving to death from the plastic, but are they getting exposed to chemicals that could impact their health? We know that phthalates have impacts on human health, and it's likely that they have impacts on other living organisms as well. And so if we're concerned with the populations of seabirds across the Maritime Refuge, this might be something that's impacting their long-term health, the overall population health. So if you move to the next slide, what we do in the lab is we take different tissues from the birds that we've dissected. Specifically, we focus on muscle tissue, and we take them to the lab and we run chemical analyses to determine concentrations of 6 of these phthalate congeners that we're interested in. If you move to the next slide, these are the chemical structures of the 6 phthalates that we look at in our lab. So DNP is dimethyl phthalate, DEP is diethyl phthalate, DBP, butyl phthalate, DBP, diambutyl phthalate, DNOP, dioctyl phthalate, and DEHP, diethyl hexyl phthalate. And if you move to the next slide, these are our results so far. So far, we've looked at about 80 birds ranging from across these species. So I'm going to sort of navigate this slide for you a little bit and give you an idea of what's going on here. So on the x-axis, on the horizontal axis, we have the different species we've looked at so far. So BLKI is black-legged kittiwake. I'm just going to read left to right. Common murre, crested auklet, glaucous winged gull, horned puffin, parakeet auklet, pelagic cormorant, pigeon guillemot, red-faced cormorant, tufted puffin, and northern fulmar. And so above the bars is the number of individuals that we've looked at so far for that species. So for example, on black-legged kittiwake, we've looked at muscle tissue from 6 individuals so far. And the bar represents the sum of the concentrations of the 6 phthalate congeners we've looked at so far. So we gave the muscle tissue to the lab. We asked them to quantify the concentrations of each of these 6 chemicals. And then what I did is when I got my results back, I added that up across for each individual, and then I averaged it out. So this is the average of the sum of the phthalates for 6 individual black-legged kittiwakes. And so if you look across the board, the sample sizes are pretty small for some of our species, and then if you look at something like crested auklet, the CRAU, our sample size is about 20, and you can see that it's relatively higher for those birds in relation to the other species. And the picture of the little birds with the orange beaks and the blue eyes, those are the crested auklets. And we think that what might be happening is that they eat plankton. And so they might actually be specifically targeting microplastics because they look so much like plankton. And so they might have a higher risk of exposure to these chemicals because of the way they eat. The other birds that I'm really concerned about that we've found lots of plastics in so far are the northern fulmars, which are the ones on the bottom, and it's the column all the way to the left, only because more often than not we're finding plastic inside the northern fulmars. And I also think that has something to do with the way they eat as well, because what they'll do is they go after krill, which can lay at the top of the surface, and they'll skim the krill off the surface and sort of not be filtering out anything. And if these small pieces of plastic are floating at the surface and mixed in with the krill, the birds are just going to swallow it all together. And so they often end up with plastic in their stomach. And in the Arctic, they've actually been used as an indicator of understanding the extent of plastic pollution across the Arctic because they're found in all parts of the Arctic. They're a pan-Arctic species. So basically, the moral of the story with this slide is that every bird we've looked at so far has had some level of some phthalate in its muscle tissue. So no bird was entirely clean. Every bird was exposed to at least a phthalate. And not all of those birds had plastic in their stomach when we dissected them. And so what that tells us is that at some point in its life, this bird was exposed to plastic in some way. And we can use phthalates as a tracer of that. So if you move to the next slide, and this will be sort of where I'm going to wrap up a little bit here. Some of the birds that we dissected were actually gravid females, so they had enlarged reproductive tissue in their bodies when we dissected them. And so we took out that reproductive tissue and tested it for phthalates. And every single one of those, it was a small sample size, it's 11 right now. Every single one of those reproductive tissues also had phthalates in them. And so if you move to the next slide, it raises the question of how will phthalate exposure during development impact seabird chicks? So if their egg is already forming with phthalates in them, are these birds being exposed to phthalates as they develop into birds? And what does that do for them if we're thinking about the fact that phthalates are going to interrupt hormones? If hormones are the signals that our body uses to develop, to grow, if you have something from the outside interrupting that signal, is that going to mess up your health? Is it going to mess up their behavioral health? There's another study out right now with juvenile fish that got exposed to polystyrene, and they saw that those fish that were exposed exclusively to polystyrene, they lost their predator avoidance behavior or instinct. And so when they tested their behaviors, those fish did not avoid the predator. And so there seems to be this link with development and exposure to these plastics, to these chemicals. If you move to the next slide, there's only one study out there right now that was an experiment looking at injecting phthalates into eggs as they developed. So they used chicken eggs. And at every level of exposure, the hatching success was reduced. So it was a significant amount of reduction. If you move to the next slide, if the chicks were born having been exposed to phthalates, then they were born with serious birth defects. The biggest one being gastroschisis, which is basically what happens is that in the last days of development, the tissue around the sternum is going to close up and keep everything inside. But when gastroschisis occurs, that doesn't happen. The tissues don't close up, and so basically the birds are born with their insides out. This actually happens in human populations as well, but if you're a baby born in a hospital, the doctor can sew you up and keep all your things inside. If you're a chick in the wild and you're born with your insides out, you're probably going to become someone's lunch. So if you move to the last slide, now what our findings are saying is that these chemicals are moving through food webs and also through generations, including into seabird eggs. In Alaska, there are communities that harvest seabird eggs. So what does this mean if there are places where seabird eggs are being harvested, if those eggs have phthalates in them? Now those phthalates are moving into the human population. So humans are getting exposed to, like, potentially. I'm not saying that this is actually happening because we haven't done that part of the study. We haven't tested humans who are eating eggs to see if they're exposed to phthalates. But it raises the question of whether or not they could get exposed to phthalates through subsistence harvesting and what that would do to human health. And so I'm going to sort of conclude this with the idea that it's sort of a what goes around comes around, in the sense that when we're using plastics and we're throwing them away, if those plastics are ending up into the environment and animals are potentially ingesting them, the chemicals that are associated with the plastics could find their way back to us in this crazy way of, you know, things that we can't even see. Because you can look at a mer egg and not know that it has phthalates in it. Phthalates are not, you know, they're chemicals. They're not things that we can see visibly. We'd have to, like, test for them. And so it really kind of goes to show just the reach that plastic pollution can have on the environment and on human health. So with that, I'll wrap up right there. The last slide is my thank you slide, and I'll throw it over to Diana again, or Christie.
Thank you, Veronica. And just as a reminder to everyone, there will be time at the end of the call to ask her more about her research. So we will leave some time for Q&A and discussion. So hold on to your questions, because now it's time for me to welcome and introduce our next speaker. Christie Keith is International Coordinator and the Executive Director of the U.S. Office of Global Alliance for Incinerator Alternatives, or GAIA. She joined GAIA in 2005 and has 25 years of experience with social movements and international nonprofit organizations. She began her work in Guatemala as a popular educator, program coordinator, and strategic planning facilitator for groups in the women's movement and Mayan Campesino organizing community, as well as in international human rights. And for the last 15 years, Christie has worked from the U.S. on international waste, public health, and environmental justice issues. So welcome, Christie. And
hi, everyone.
Just as a reminder, I'm sorry, I just wanted to remind everyone that Christie's presentation materials are in two parts. One is a link to a PDF, and the other was an attachment of a PowerPoint slide presentation. So
yeah,
go ahead.
So we'll start with the PDF link, and then I'll tell you when to switch over to the PowerPoint. So it's great speaking with you all. I'm going to try to keep this short so that there's plenty of time for discussion and questions at the end. The first link is actually from a presentation that was prepared by one of our member organizations, which is the National Toxics Network in Australia. And they've looked at this question of contaminants in marine plastics. And I've just chosen a few slides that I think complement Veronica's presentation. So, you know, one thing folks should know is that the reason why plastics, when they get into the ocean, become this sort of concentrator of pollution is because of the chemical makeup of plastics, they tend to sorb or like take stuff that's in the ocean. So if you have chemicals that are in the ocean, they tend to glom onto pieces of plastic. So there's been research done on plastic that sits in ocean environments, and it can be much, much more toxic than the surrounding water. And so it actually becomes a concentrator of toxicity, and it also tends to be something that's eaten by fish and by birds, and so then you have this sort of concentration of toxics up the food chain. So if you look at the second slide in the presentation, the National Toxics Network presentation, it talks about how the American chemicals and plastics industry sees plastics as sort of the building block of a modern economy. And I would say that actually capitalism rests, you know, one of the cornerstones of capitalism and of sort of global capitalism and global capital concentration is plastic, because it allows us to be shipping products overseas and sort of displacing local markets for global product supply chains. So move to the next slide. So this is, you know, plastics really are sort of a new toxic time bomb if you look at them and how they're concentrating toxicity up the food web. So So you've got the global transport of persistent bioaccumulative toxics through plastics. You've got the increase of microplastics from pellets, ropes, nets, microbeads, synthetic fiber. Polyester fiber, when it's washed, it's got plastic fiber in it that then is not often filtered out through sewage treatment and goes straight into the water. So there's a lot of work that's increasing right now on the idea of microfibers as a source of plastic pollution. And you've got engineered nanoparticles, and when you have really tiny pieces of plastic, you've got a lot of surface area to a small amount of volume, which means they tend to concentrate toxics even more than if it's a big chunk. And so there you have PCBs, DDTs, lindanes, BFAs, BFRs. So, phthalates, all the different types of chemicals that one might be concerned about tend to concentrate on pieces of plastic. And so, you heard Veronica talk about phthalates that might be in the plastics themselves, and you've also got this concentration effect. So it's deeply concerning. And I want to say one thing about one of the data slides that Veronica shared that talks about where plastics are coming from and showed some countries. One of the narratives that's being told, in part, there was some modeling research done to look at where is macroplastics in the marine environment coming from. And the modeling research, which wasn't actually field research, said, well, the biggest problem is Asian countries, and a lot of that has to do with these are islands. And so when they modeled it, they said, well, a lot of people live near the edges of the islands, and they use plastics, and they may not have good waste management systems, so we assume that a lot of plastics are coming from their environment into the oceans. And what we do know is that there is a serious problem with plastic pollution in Southeast Asia. But we also know that in the United States and Europe, we use a lot more plastics. We generate a lot more waste than people in Asia do. And we use a lot of things that produce microplastic pollution. So at GAIA, we're interested in sort of saying, yes, there's a problem with plastic pollution, and our members in Southeast Asia are saying, yes, we want to work on solving this problem, and at the same time, let's not overestimate or put too much responsibility on just a few countries for causing the problem, when really it's probably a problem that we're all contributing to. So anyway, the microplastic issue is a very serious one, particularly in the United States. If you look at the types of plastics and additives that we're talking about, which is the next slide, you'll see a list of different types of additives of concern. Again, flame retardants, stabilizers, colorants, and a lot of different persistent organic pollutants that you might be looking at. And then the final slide here is, it's not quite the final, but the second to final. International Pellet Watch looked at levels of chemicals in different pellets, which is the sort of building block for plastic that's been recycled or is being made into new materials, and has actually, if it's been spilled into the ocean by mistake, what then happens to it. And you'll see that, in some of these pellets, you have very, very high levels of PCBs, DDTs, and other types of pollutants. So again, radically varying levels, but pretty significant levels in terms of what is considered safe. And then there are some other studies that have been done. So the 2014 Norwegian Institute for Water Research, which is on the slide called Levels of Pollutants and Other Microplastics, has also looked at some of the chemical compounds that glom onto the plastics. So, I'd like folks to now turn to the other set of slides that are attached to your email. So I'll give you a minute to go back to your email and open that up. And there's a presentation there. Because what you've heard so far is all sounds pretty dramatic, pretty dire, and really focused on this problem of chemical pollution. What I want to tell you is that there are people around the world who are organizing to say, we're not going to accept this, We want to turn the tide on plastic pollution, and we want to turn the tide in a way that might be different from the approach of just trying to go out into the ocean and clean it up, or just trying to work with companies on better waste management systems, but actually trying to shift away from such enormous amounts of plastic use. And so as GAIA, we're part of the Break Free from Plastic movement, which includes a lot of other organizations. And here's a presentation on that movement. And if you'd like to get involved, there's a website where you can join, or you can also contact me personally. So turn to the second slide in that presentation. And it talks, and here we're saying that we want to stop the problem at its source, and our goal is to reduce production by a lot. It's not just to manage the production that's out there. It's not just to pick up the litter. It's to reduce the production of this very problematic material. The next slide talks about who we are. So we're a campaigning and movement building initiative that's anchored by strong global and Asian regional organizations, and GAIA is one of the lead organizations in this initiative, along with the Story of Stuff Project, Oceana, Greenpeace, and many, many different organizations from the region. We're dedicated to North-South leadership, partnerships, and power. And back in last July, we had activists from 50 countries who met in the Philippines. We created a common strategic framework and vision, and we support local, regional, national, and cross-border organizing. And you can look on the Break Free from Plastics website to see a video that talks about our vision, which is the next slide. This is a shorter version of our vision. We have a vision and principles statement that's online. And the shortest version of our vision talks about the fact that we believe in a world where the land, sky, oceans, and water are home to an abundance of life, not an abundance of plastic, and where the air we breathe, the water we drink, and the food we eat are free of toxic byproducts of plastic pollution. In this world, the principles of environmental justice, social justice, public health, and human rights lead government policy, not the demands of elites and corporations. This is a future we are creating together. So in terms of the action that we're taking, if you go to the next slide, you'll see that, right now in the world, like actually this week, there's this massive mobilization of students, local governments, and NGOs from the Philippines and Indonesia that are involved in a big zero waste festival in the Philippines, and they're working on a Filipino ban on plastic bags as well as local waste solutions. Also, groups in Europe have come together under the leadership of Zero Waste Europe to influence the circular economy policy in that region, and they're setting positions on bioplastics, extended producer responsibility, and other things. And if you scroll forward, you'll also see that Greenpeace has been taking some actions around corporate behavior and sort of said, look, it's not enough to just have voluntary agreements. We need strong policies, because when it's just voluntary, implementation of, for example, microbeads bans becomes very uneven. We need strong standards that drive the corporate commitments. So if you move on to the next slide, it talks about making change happen. And these are just some of the victories in 2017 that were achieved by Break Free from Plastics members. This isn't everything by any stretch of the imagination, but we're talking about microbead bans, styrofoam bans, we're talking about tariffs on plastic bags, we're talking about policies and victories against incineration, which just puts plastic pollution into the air. We're talking about phase out of disposable utensils and plates and spoons in several cities and countries. And we're talking about, some pretty significant policy initiatives in India that could be very far-reaching if they're implemented. We also are, if you go to the next slide, you'll see that we're also well aware of the scale of the challenge. The plastics industry projects exponential growth. As the price of oil has come down, the availability of the stuff that makes virgin plastics has increased, and so there's a real interest on behalf of the plastics industry or the oil industry to put, excess oil, excess raw material into plastics. There's more waste, less of it's recyclable. That's the projection of the industry. And the sort of what we see is this idea that we just have to manage this stuff better. And one of the big things that the plastics industry has been promoting are sort of studies that say we just need to build incinerators that would, that would solve the problem and really put plastic pollution into the air. So here you'll see some members, members of a waste picker cooperative in Pune, India, who did research on what were the most problematic products for their systems. And part of our vision statement talks about we're not content to simply manage a problem created by someone else, but are seeking to transform the system. So again, last slide, we really aim to stop the problem at its source for a future free from plastic pollution. Thank you.
Thank you, Christy. Sorry for the delay there. I had to unmute my line. So this is the time now when we'd like to invite questions and comments from those of you who have been listening. So if you would like to ask a question, please press please press star 2 to unmute your line, and please state your name and affiliation. We have about 10 minutes for our discussion, so just keep that in mind so that we have time for several questions. Again, star 2 to unmute your line. I know we have about 40 people on the call, so I'm just imagining that somebody out there has a question.
Hi,
Hello,
this is Patty.
Jesse Marquez. Can you hear me? Go ahead.
I'm sorry, I'm not sure who was coming in first there.
Go ahead. I'll wait.
Hi, this is Patty from Anchorage, and my question, if people were going to start in one place and not tackle the entire problem at once, is there one type of plastic that is more problematic either from a volume perspective or a toxicity perspective that is where they ought to start?
I can tackle this question if that's helpful. So the stuff that you see the most in the marine environment is the stuff that you use the most and get the least time of use out of. So we're talking single-use, disposable, unrecyclable junk plastics. So this is one of the reasons why plastic bag bans has been so prominent for coastal communities. Their plastic bag is sort of a ubiquitous pollution problem, and they're used very short-term life, and then they get disposed of. They're also light; they easily blow into the ocean. So there's some data that you can find on what are the worst plastics for the marine environment, but we're talking about single-use disposable junk. And so bag bans, cigarette butts tend to be an issue in coastal communities in some places if there's a lot of smoking. Depending on the region of the world, some places it's like little single-use packages of like shampoo, and some places you're talking more about the caps from water bottles, depending on the region of the world. But you want to look at what's the most problematic material in your community, and that's where you start.
Thank you, Christy. And now I'd like to move on to the man who had a question as well.
Yeah, this is Jesse Marquez. I'm the founder and executive director of the Coalition for a Safe Environment. We're an environmental justice organization located in Los Angeles, but specifically in the community of Wilmington, where the Port of LA and the Port of Long Beach are located. Your presentations were outstanding. The good news is that January 1st, as of this year, California has banned single-use plastic bags throughout the state, so that's one little contribution there. But then we'd also like to get your advice as to what would be like another next step that we can take to help, stop plastics in the ocean.
So another material that's really problematic to waste systems, and also it's problematic on lots of fronts, is styrofoam. And many cities are sort of taking local action on banning styrofoam for food delivery, et cetera. That's another step. Like if you're going material by material, there, you want to look at what's the most problematic stuff, and styrofoam is significant. I would say the other thing is to look at, joining up with some of the organizing that might be happening that's more, that might be looking more holistically at the situation in the region or in the state. Some countries and states and localities are looking at putting tariffs or fees on, on disposable plastics. That would be a really radical idea for California that I think would be great, not just going material by material. There's going to be this year corporate campaigns that will be launched to put pressure on some of the big brands around their single-use disposable delivery systems. So, there's packaging. So there might be some corporate campaigns that folks might want to get involved in. So depending on your interest, there's lots of ways to get involved, I think.
Okay, thank you. I would like to ask a favor then. Could you also now, those of us that are on this call, send us, a summary or, who's doing what so that, I can team up with somebody in doing some of these things? That would be a great help versus me trying to just find things,
Sorry, I was hoping to jump in here only because in California, I'm an ambassador for an organization called Five Gyres. I don't know if you've heard of them. And Five Gyres is doing a lot of great stuff. Plastic Pollution Coalition is actually also based out of California, and they're doing a lot of good stuff too in terms of movements and getting information out there. I really like teaming up with those folks, and it's because they're California-based, so that actually works really well for you. The other group in California is the Algalita Research Institute, and that one's the one founded by Charles Moore, who is sort of one of my personal heroes. But he brought attention to the giant garbage patch in the Pacific Ocean. Like, he's the one who sort of made people very aware of that going on, or at least one of the people who made us aware of what was happening in the Pacific Ocean. So those three groups are all based in California and are doing a lot of good work in terms of outreach, education, and sort of, petitions to ban. I think they had a big microbead ban petition going on. And right now, actually, for Five Gyres, their big one is styrofoam. So just to add on to what Christie was saying, that might be a place to think about where to start.
They're all part of the Free from Plastics movement. So if you go online, you can sign up. They're also all Southern California based, so they'd be good for you, Jesse.
So this is Diana facilitating the call, and I just wanted to respond to the suggestion that there be some follow-up resource, and we always do like to send out an email after the call with a link to the recording as well as additional resources. So what I'd like to propose is that all of you who are listening, if you have additional resources, groups that are working on these issues, if you could send me an email today, Diana, D-I-A-N-A, at akaction.org, I can list some of those organizations and links, and that will make it that much easier. And congratulations on the California bag ban.
Can you repeat that email again?
Diana, D-I-A-N-A, at akaction.org. So I'll try to compile something just based on what participants, the organizations that they're aware of and are connected to.
Thank you.
We do have time for probably one or two more questions, either about Veronica's presentation about the Bering Sea and the seabirds, or Christie Keith's presentation. Or comments.
Hi, Diana. This is Pam with Alaska Community Action on Toxics with a question for Veronica. Veronica, I was very interested in the work that you're beginning to do looking at exposure pathways of contaminants through seabird eggs, and I wondered if you might say a little bit more about that, and if you're looking at additional contaminants in addition to phthalates, such as some of the persistent organic pollutants, including PCBs and pesticides.
Sure, and thanks. I actually should have brought that up. So one of my biggest concerns has been that since when plastics and we talked about this, when plastics make it into the marine environment, they're acting like a sponge and, taking up other chemicals besides the phthalates. And so if a bird is ingesting a piece of plastic, it's not necessarily just getting exposed to phthalates, but possibly all of these persistent organic pollutants. And I've been curious to run tests to see if there are correlations. If a bird has phthalates, is it at higher risk of having, PCBs in its system? Are there relationships between those things, and are there relationships in the sense of like if it's moving into seabird eggs or something like that? Unfortunately, we haven't gotten to the point where we can test for PCBs. The lab analyses are very intricate and complicated, especially with phthalates, because basically the lab had to revamp itself entirely so that it was as plastic-free as possible, which is not easy when we use so much plastic. And so the phthalate analyses in and of themselves are laborious and expensive and time-consuming. And so we've gotten through that first step, and I hope in the future we can run those same tissues, like muscle tissue from the same individual that I have phthalate data for, look at PCBs as well. Look at mercury. There are some studies out there that are doing associations between like plastic ingestion and heavy metal exposure, not necessarily looking at phthalates as well, but sort of trying to correlate those sorts of chemicals. My hypothesis would be that if plastics are absorbing these chemicals, then an animal that's ingesting plastic is at higher risk of getting exposed not only to phthalates but to PCBs. I don't have those data. I'm really curious to know as well, because I think it's a possibility. Does that make sense? I'm sorry, I kind of rambled a little bit, but it's not an easy question to answer.
Thank you. Time for, well, actually we are about out of time since I have a few wrap-up comments to make. So again, I just want to thank everyone for participating, and I want to thank our presenters for their time today as well. Christie, I guess I should just give you an opportunity if you have any final comments you'd like to make.
Oh, I'm great.
Okay, great. So yes, I will be sending a link to a recording of the call. I will send further resources either suggested by our presenters or by any of you that are participating. And as a final note, if you found what you learned today to be valuable, I hope you'll consider supporting our calls with a donation. And you can always donate online at www.kaction.org and just click the Donate Now button. We will have a call in February. We don't have the details worked out all the way yet, but we will be sure to announce that to you. You'll receive the announcement and a way to sign up for that. So thanks again, everyone, and have a wonderful day. We appreciate your participation.
Thank you.